July 28th. I think I just had probably the worst session in recent memory. It was so bad. I can't even clean 205 today. For whatever reason, I feel powerful. I feel good. But this bar just lands in a very bad position. And then I just kept falling. I kept losing in front. Something is wrong. Something is terribly wrong. I think like maybe my starting stance was wrong, or like I didn't keep the balance well. I don't know. Something is not right today. It's so bad. It's so bad. And I start to worry. Like it's not supposed to feel like this. I mean, does it feel heavy? I mean, I don't really think so. Like honestly, I don't really think it's heavy. It's just like the position just off. Right? Just the position just feel off. And I don't know. I really don't know. Then I think I just, no. It was bad. So I just kept doing it. It's supposed to be a 1 hour session that lasts for almost 2 hours. Just because, I tend to do this type of thing. Alright. Anyway. I'll put this behind me. And, we have more sessions. You are given a zero-indexed array consisting of non-negative integers. For each index I, you must determine the size of the minimum size non-empty subarray num starting at I that has the maximum possible bitwise OR. In other words, let Bij be the bitwise OR of the subarray. You need to find the smallest subarray starting at I such that the bitwise OR of this subarray is equal to the maximum where I smaller than k smaller than n minus 1. You'll find the smallest subarray starting at I such that the bitwise OR of this subarray is equal to the max that we can have. Okay, so I can find a maximum. Yeah, I can find a maximum of all the subarrays that we need to do. Then we need to go for is from this, I need to find a maximum subarray. No, the minimum subarray that equal to that. Okay, let's give this a shot. So we have 1, 0, 2, 1, 3, right? So this already is 3, is 1, 1. So the maximum starting from here is 3, 3, 3, 3, 3, right? So if I start from 1, I need to find the smallest I can get to 3, which is 0, 1, 2. 0, 1, 2, 3, yeah? Oh, it's the length. Length of the minimum, yeah. So 1, this is 1, 0. So yeah, so this should be 3. The second one should be 3 as well. The third one should be 2. The fourth one should be 2. The fifth one is 1. Yep. So basically I need to know, starting from here, right? I know the maximum. I know the maximum. So starting from here, the maximum we can get is 3. So what if I also go a prefix? Let me think. Yeah, I think prefix probably doesn't work. Yeah, you start from here. It is. Just add everybody together. But I need to know to where, right? The smallest. Well, if we start from here, I can just go. And once I hit something, so I start from here, I'm actually thinking about 2 pointer. I hit here, that's a 3. Okay, so I can remove this and then just keep extending. That's a good idea. So when I remove, so yeah, so like due to here, it's a 1 1. That's the first time we hit 1 1. So I need to remove this. And how do I know? I cannot do exclusive OR. Right? Because I need to notice the last one. Last is 1 0. So I have the final one, right? And then I have the maximum. And the one I need to remove must contribute to some of the ones. But what I'm afraid is, like, if I, let's see, if I have 1 1 0 2, right? 1 1 0 2. Counter. I have a counter. So I know the count of them. Yeah, so like if this is the case, this, right? And I remove this and come here, there's still 1 left, so actually it still works. It's only when it goes here. So I don't have 1 anymore. So I need to remove the impact of 1 on this. How do I remove the impact? So let's say impact is always you have some 1s and then they contribute to the 1, which means initially is 0. So I think exclusive OR can do this. So 2 pointer shall work. We can give it a shot. Let's give it a spin. Two pointers to actually should be suffix or to find the max or at each position. Max or for subarray starting at each index. 2 pointers to find the smallest subarray whose OR equal the max OR. Counter to keep track of the OR as the subarray grows and shrinks. add this, and we check. So I add this, and then we check. If it's not, then we keep going. If it's not, then we keep going. If it is, right, we do it, it is, then what do? We essentially we move, once it is, we move this one forward, right? Now we check. If it is equal, then we move it forward, and if it's not, then we do this, then we move on to the next one. I think it should be different. Should be, if it's equal, right? If it's equal, we also need right, so basically we say if it's not equal, then we will move forward, then we'll change it, and then now we'll continue. Right, we'll continue, and we move forward, and if it's not equal, if it's equal, then okay, so if it's equal, current or is equal to maximum, then we'll say res I j minus I plus 1, and then we'll do counter nums I minus minus, right? Counter nums I minus minus, and then we'll say if counter nums I is equal to 0, then current or exclusive or equal to nums I. If it's not, then we don't change, and I plus plus. Right? And we'll continue. We'll continue. So J now, J don't move forward. Don't move J forward. Right? Don't move J forward. Then we check again. Okay, so don't move J forward. Right, don't move J forward. So if it's equal, then we do these operations, and then we go back up. We check again. Right, current or if it's equal, then we'll do it again, and then we will keep on. Otherwise, we'll do exclusive or, and then we go back again, and it's not equal. So when it's not equal, I think I can do this else, right? So if it's not equal, then we say current exclusive or, current or nums j, right? It's not equal, so I need to add a current one. Counter nums j plus plus, right? And then j plus plus. We move j to the next one, and then we check. again. Right, then we check again. Oh, then J points into the next one. I want J to always point to the end. So if that's the case, then I should do J++ here. Right, so we start the first one if it's and also should be I is I should be smaller than J. If I is smaller or equal to J and current is equal to, okay, then I do this I plus plus. It's smaller or equal to J, I plus plus. Then I can maybe larger than J. Then we do this J++. So we do that, then we do that. And then I try it again. So yeah, now every time when we check, J is always pointing to the one that's currently pointing at. And I is pointing the one that's currently being pointed at. So yeah, we just keep doing this. So I++ all the way until J++. J++. Yeah, so I'm thinking about J is reaching the end. Okay, so current OR is all to the end. Now I go back. This must be equal. And I start to shrink. Now we need another one here. Yeah, feels weird. j plus plus. Oh, yeah, this is wrong. Shoot. I should add the current one, then plus plus. So, okay. Then, so add the current one, then plus plus. Then the next one coming up, so we check is not good. Add the current one, then plus plus. The next one is good, then j is pointing to the, so I do this, right? And then when it gets out, right, because j can plus plus and j become larger, and then with that, then we can just continue, right? We can say while, hold a second. So I can say, or I is smaller than n, right? And then if j goes out, I is not, then we can do, yeah, we'll keep doing this, keep doing it until, okay. Let's try this. Now this one seems a little better. Huh. How is that possible? How is that possible? Okay, so current or counter yeah, so I know we have one. Second, current not. Second is 0. Third one, 3. So j is 3, okay? 0, 1, 2, 3, j is 3. So now this is equal. So rest the first one becomes 3. Yep. And counter is equal to 0, so I do this, so exclusive should be 2. Yeah, it's good. Now I plus plus, I should equal to 1. Good. Next, does not equal, so we get the next one, now becomes 3 again. And we get a 1, and another 1. I now equal to 4, or j equal to 4. Coming here is equal to 3. So we do this, so next one is 3. That's good. So now we get rid of 0. Okay, 0 get rid of. Then this is 0, but current all does not change because it's a 0. That's right. So I plus plus, now I become 2. Right, I become 2. Go next one, that's equal. So we get 2, and then we remove 2. So we need to do exclusive for 2. So this should be 1. Current should be 1. That is right. So I plus plus. Now I point is 3. 0, 1, 2, 3. Yeah, I is 3. J is 4. So it's not equal. So I do this. Now it becomes 3 again. So J goes out. Okay, J is out. But this is fine. So we have 2. That is right. And I remove 1. Oh, I remove 1. Holy crap. Yeah. do this exclusive or I should not do this exclusive or. Damn it. Damn it. I think, yeah, this is not gonna work. So like current is 1, right? And only one of them, but the other ones also, I need to track the number of set bits. Okay, I need to track the number of set bits at each position. Right? Use that to decide number of set bit at each position. So I'll go through every single bit, and if that bit position has more than 1, then you remove it, doesn't matter. But if there's more, then it matters. Okay, so what I'm saying is, and this is 10 to the 9th, so a 32 shall work. So the counter is not this. A bit counter to keep track of the all. So here we can do a vector of int and counter, but this is size 32. Okay. So we need to update counter. Okay. So nums j, and then we shall say int temp nums j. We can do temp here. Temp. Right. So we say temp equals this. While temp is larger than 0, if temp, oh, I need to know which bit. Right, I need to know which bit. I might as well just. Yeah, actually no. I don't need a temp. I do not need temp. I do not need temp. I just go through the whole. Let's say for int k equal to 0, k smaller than 32, k plus plus, right? For each one, we say if nums j and 1 left shift k is larger than 0, right? Then we shall say counter j. At this position, I have more, not counter j, counter k. At this position, I need to do another one on this. Right, so 1 left shift k, then counter, it's a bit counter, right? A bit counter. So at this position, I get another one, I get another one. Okay, so that's fine. And then here, right, I'll remove this. So what I do is I do the same thing. I will do for int k equal to 0, k smaller than 32, k plus plus, if nums I and 1 left shift k, right? If this is larger than 0, then I do counter at position k minus minus. Now we say if counter k is equal to 0, which means this bit need to be unset. Then we say current or how do we unset? I can do exclusive or equal to 1 left shift k, right? So this bit need to be unset. So we go through all the bits to see which one. If it still has, then we cannot unset it. So I do that, blah, blah, blah. Don't do this. don't do this, don't do this, and I move on. All right, let's see if this one works. So let's put a bit manipulation. Okay, this one seemed to be good. Let's try it. Oh, you gotta be kidding me. So both are 0. Current exclusive for is 0. So we come in. So it's equal to this. It's actually yes. Because J is pointing to. So what? J needs to point to what? Yeah, it's the loop variant is actually not right. So maybe what we need to do is to set this to be nums I, okay, and nums 0, set j at 1, so it's very clear when we start, and then so basically the first one's already done, and then you can keep moving on. I think this one shall be right. No, it's not. How is it still not right? Oh, it didn't update this thing. Oh, shoot. Then what? Maybe I can do. Okay, so let's set this to 0. And j is set to 0. Then comes in -1. -1 doesn't work. -1 doesn't work. Because you need to current or we need to or something. So yeah, it has to be 0. Maybe we can set I to -1. If I to -1, that also doesn't work. How about we do this one first? Okay, we always add it. Then, so basically, we always add this one first. Okay. So we add this, and then we say this become a while loop. While this is smaller than this, and this is equal to this, I do this, this, plus plus. Okay? And then, because it's a while loop, I'll keep going. And then we say if it's still equal to, until it's not equal to. Then I'll get out. Which means I can say, maybe I can still do a for loop. We go back to for loop. Alright, we go back to for loop. Always add this. And then we do a while. To check. Alright? And maybe this is the way. I got a bit confused of how. Oh my goodness. Should be +1. Right? It should be +1 because now we are talking about j is pointing to the 1 that should be included. All right, let's try this. Okay, now it's correct. Yeah, it is a for loop, and then it's a while loop. I think I forgot how this one is usually done. Not really hard. It's not hard. It's just, I don't know. I'm not in the best shape today, both mentally and physically. Enumeration. Is it similar to my idea? If it's 1, then after performing a bitwise OR operation with any number, this binary bit remains 1, so it has no effect. If it is 0, then we need to find the smallest j such that j larger than I and the bit binary is 1. This way we can achieve the maximum value through bitwise OR. So that such j may not exist. Traverse the array nums in descending order. Traverse in descending order while using array position to recall the most recent position where each binary bit was set. When we reach nums I, for its ith bit binary digit, if it is 1, we update position to I. If it is 0, and this is not -1, then we obtain a maximum bitwise OR value with I as the left boundary, and the right boundary must be at least minimum right boundary for each I as the set. I don't quite understand. So I go I from right to left, right? So j equal to I, This is bit. So I say if it's not, so it's a set bit. Position bit is not equal to -1. So it's a set bit, right? And we update j, maximum j, and then position this. If position bit is equal to -1, which means this is the first time that position bit gets set. No, this is the one that's 0, right? Yeah, this is the one that's 0. This is the one that's 1. Now I'll set the bit to I. This is the one that's 0. So if it's a 0, I obtain a j, which is the maximum. What's position again? To record the most recent position where each binary bit was set to 1. Most recent, so it's most to the left, that's set to 1. So this means that we go through every single bit, right? And if my bit is a 0, then I need to find a bit to my right that has been set to 1 previously, and I'll get the j, which position it is that set it to that make it a set bit. If I am a set bit, then I update it to my set bit. So I go through all 32 positions, right? I go through all 32 positions, and at each position I'll find, so j, basically what I'm finding the j to be is the largest index that can make an unset bit to make it set, right? The largest bit that can do that. And at the end, I say that one will get us. So essentially, what happens is I have the position array, which records the most recent, right? The most recent index that has a bit that's set, right? So this is what this is. And then for the current number, what I want to know is, because from the current number to the end, I have different bits that can be set, right? Different bits that can be set. And if a bit that is set for me, for the current number, then I don't care, right? What I care about is if a bit that is not set for me, right? If a bit that is not set by me, I want to know who can make it set, right? I want to know who can make it set. So I'll use this position array, right? This position array can tell me at this position who make it set, which one is the leftmost that can make it set, and we'll know it if it is not equal to -1. That means yes, we can make it set. So I'll find it, right? I'll find it. But then at different positions, you might have different index that can make it set. And since I want to make the maximum value, I wish every single bit is set. Then I need to find, basically this is find the maximum, the max min, right? The maximum index among the minimum that can make the most set. That makes sense. Wow, this is a very different way of thinking. I don't think about it this way. For me, it's 2 pointers, and I'm using the bits. I'm doing a bit counter. This is enumeration. I think the second time, because this one is enumeration as well, right? This problem is enumeration as well. This is enumeration, and this is enumeration. What the hell is enumeration? It seems to be a very interesting approach, but kind of counterintuitive. Kind of counterintuitive. more practice on enumeration. This is an example. Wow, somebody really did the work to draw this. Well, good work. Somebody has 2 lines. Yeah, I don't really think about 2 lines anymore, but this enumeration, gotta understand. How did you even think of this? I mean, the way they think about this is, well, first you iterate from right to left. That's fine. I can think of that, right? Iterate from right to left. And then what you need to know is you're starting from an index and you want to find the minimum that can make the value max. I think this is the first divergence. In my method, I find the max first, right? If I find the max first, and then I will try to match it. And if I try to match it and I want the smallest subarray, yes, usually it's 2 pointers. That's kind of just straightforward. But here, they don't really find the actual value of the max. You don't know what the max value is because you don't care what the max value is. What you care about is starting from an index, right? I want a maximum the OR. That means I want all the unset bit to be set, right? Unset bit to be set. And then, following this logic, if I want the unset bit to be set, I want to know which number or which index, right, in the array can help me set every single position. And that should be the earliest index. So which number to my right, that's closest to my right, can help me set every single bit, right? And then I need to have, so I'll go through every single bit, and so for each one I'll check if there's a number that we encountered before can set it. That's why we have the position array, and the position I is for this bit, which index can make it set, right? Which index can make it set. And then I go through all of them except for -1. -1 means there have not been any number that can set this bit, right? If it's not -1, then someone can make it set. And again, if my current bit is set, then I don't worry about it. If my current bit is not set, then I go to the position array, I get the leftmost index that can set it. And then I go through all of them, and then I need to find the maximum of all of them. And that setup can give us the max OR. Okay, I think I understand. But boy, is this complicated. Pretty complicated. Anyway, I think my default go-to will still be 2 pointers. It's easier to understand. This is pretty hard to understand, honestly. Alright, anyway, that'll be it. I think this is a good one. And I'll see you guys tomorrow.